right, so this unit is going to be a short, kind of quick, fast unit, but I will tell you that it is super important. We're going to use a lot of this. So the first day of notes on our first thing of notes is going through just what a function, an ordered pair, and those types of things are. And so you should know a lot of this, but just to review, because you're going to need it as it gets harder, is a coordinate plane is a plane divided into 4 regions used for, why did I say fro? Some days English, for graphing. Okay, so I would like you to take a second and I would like you to label the origin, the quadrants, the x and the y-axis. So just take a second and do that. Okay, so if I start with the origin, my origin is right here at 0, 0. Okay, and then if I go ahead and do the quadrants, this is kind of, kids always ask why it goes backwards. And so this is quadrant 1, and then this is quadrant 2, this is quadrant 3, and this is quadrant 4. Okay, well, the reason it goes backwards is kind of above this class. But what happens as you go on in trigonometry and like polar coordinates and calculus is you have these angles, and if it's spun positive, it would go up first. So if you imagine this line right here, this orange line, if you imagine this orange line, why is it not playing nice? This orange line, and you're spinning around, this way, that's the way that it hits the quadrants, 1, 2, 3, 4. So that's why they're backwards. That is the correct way. You kind of have to know the quadrants. Okay, we know that our x-axis is that axis. And then finally, we know that our y-axis is the vertical axis. Okay. So an ordered pair is just an XY point on the graph. And when you do an ordered pair, you always do X and then you do Y. Okay, so if I were to name the ordered pair in this, I'm going to just start with A. I'm going 1, 2, 3. I'm going 3 back, and I'm going 4 up. So the ordered pair is a -3, 4, and it is in quadrant 2. Okay, and sometimes they'll use Roman numerals. So they'll do this for quadrant 2. I don't really care. If you want to use Roman numerals, you can. So I would like you to take a second, and I would like you to pause this video, and I would like you to name the other points. All right, so B is 2, -3, and that's in quadrant 4. C is 0, 2, and that is not on a quadrant. It's on the y-axis. Some teachers teach none, but I think that's confusing because it is a point. So I don't want to say none. It's just on the y-axis. Okay. Point D is 7, 1, and that's in quadrant 1. Point E is a -4, -6, and that is in quadrant 3. And then point F is a -5, 0, and that is in quadrant X-axis. I would much rather you wrote that than none. Okay. Now, continuous and discrete is going to be important as you move along. So this unit is short, but it's got a lot of important information. Okay, so a graph is a discrete graph if it is a graph of distinct points. I apologize for my old dog. He's sleeping, and you can hear him snoring. So this might be like shoe sizes, people's shoe sizes. They're just distinct points. It doesn't connect, okay? And then a continuous graph is a graph connected with lines and curves. Okay, so a continuous graph would be like something like this. Okay. All right, so we're going to talk about relations next. Okay, a relation is a set of ordered pairs. Okay, and the set of the x values, this is huge in everything we're going to do. The set of the x values is called the domain. The domain is going to be really important to you as you move along in math. So it's the things that you can put in. Okay, for example, if you have a job, you get paid by the hour, that's a relation because the more hours you work, the more money you make. But it does have a domain. You can't work negative hours. You can't work 1,000 hours in a week. Like it does have values that it can be. So the domain is going to be important as you move along. Okay, the set of all the y values, he is napping. Okay, the set of all of the y values is called the range. Okay, so you would list them as a set. Okay, this is also important. Same example. You have only things that, like if you work 10 hours, you can't make negative money. So your range is your set of values that your y's can be. So if I look at this and I look at the domain, it wants the domain, that's all of these x values in the relation. Okay, and so I'm going to list them. My range is a -3, -2, 1, and 3. Now, the next one is a -3, but I already have a -3 written, so I don't need to write it twice. Okay, I would strongly suggest not writing it twice because it's going to kind of affect your answers as you move along. Okay, so same thing with your range. Your range is all of your y values. So my range would be 1, 0, 2, -4, and 5. Now, some teachers make you put those in order. I don't really care. It's for what you're going to need in the world. The order isn't so much going to matter. I just wouldn't write them twice. Okay, I won't take off or anything for it. Then they want you to put it into a table. So you have a -3, 1, -2, 0, 1, 2, 3, -4, -3, 5. Okay, so the tables should be easy. And then they want you to map it. So what you're going to do is you're going to take all of the ones in your domain and you're going to put them as your x's. -3, -2, 1, and 3. And then you're going to put all of your values of your range as your y's. Okay, and then you're going to map it. So you're literally just going to take and connect them. -3 goes with 1, -2 goes with 0, 1 goes with 2, 3 goes with a -4, but -3 also goes with a -5. So you have 2 coming out of there, which is going to be important to us as we move along. And then you graph it. So you have a graph at -3, 1, -3, 5, 1, 2, 3, 4, 5, -2, 0, 1, 2, and then a point at 3, -4. Okay, so there's my graphs. All right, so what I would like you to do right now is I would like you to pause the video and I would like you to fill out the next 2, please. Okay, so my domain on this one, if you should on pause, -2, -1, 0, 2, 5. And my range ends up being -3, 4, -2, -4, and a -1. So none of them repeat. So then I can put that in a table, -2, -3, 0, -2, 2, -4, 5, -1. And then my mapping, none of them repeat. Oh, why they make it so difficult? -2, -1, 0, 2, 5, -3, 4, -2, -4, -1. And when you map it, they all just match up. Okay. When I graph it, I have a point at a -2, -3, -1, 4, 0, -2, 2, -4. Oop, that was 1, -4. And 5, -1. Okay, and then the next one, my domain is, we're going backwards. My next one, I know my points. So if I do this first point, I know is 1, 2, 3, 4, 2. So I'm going to put it here. And then this point is 0, -3. This point is 2, -5. This point is 1, 2, 3, 4, 5, -4. And then this point is -2, 3. Okay, so if I do my domain would be 4, 0, 2, -5, -2. My range would be 2, -3, -5, -4, 3. And if I do my map, they just all would go together. And then I would connect them. Okay. All right, so we're going to kind of move on with these notes. So we're going to go to this page. We're going to have a lot of notes on this. So for your domain, when you list your domain from a graph, this is going to be important. You're going to scan your pencil from left to right. Okay, and identify the X values that are touching the graph. And on the range, you're going to go from bottom to top and identify the I don't know why that's an and, bottom to top. Okay, so what I'm going to do, I'm going to just kind of show you how this goes to find my domain, and we're going to write it in what's called set notation. So you're going to start over here to the left, and it exists, and I'm going from left to right. I never picked up my pencil, right? I never picked up my pencil from left to right. So we're going to write it like this, -infinity to infinity. What that means is, because these arrows are going out at the end, what that means for the domain is that it will go on forever from left to right, okay? Now, this is where this gets tricky. And so I'm going to show you right here. If I look, I start at the bottom. There's no graph there. My graph does not start until right here. That's where my graph starts. And then it continues up, going forever. So my graph is not a -infinity to infinity. It actually starts at a -2 because that's my Y value right here. This point is 0, -2. Okay, so it starts at a -2 and it goes up. Let's discuss these. We've talked about them before. This needs to be a bracket because there is a point there. Okay, and infinity, it doesn't have a bracket, and we get into arguments on this because we're going to write ours in set notation. Every year when I teach this and review this in Algebra 2, I have kids that are like, well, why doesn't infinity have a bracket? Okay, well, infinity doesn't have a bracket because we don't really know what infinity is. We just know it's the biggest number that we know. It goes on forever. So, like if you said the biggest number you knew, and you said a gazillion, I could say gazillion and one. So I could get bigger than yours. And we could just keep playing that game. So they use parentheses there to show that we don't know where infinity ends. But we use a bracket because it ends there. Okay, so let's take a look at the next one. So if I go from left to right, left, this is the farthest left it goes. I'm going to write the point, -1, 2, 3, 0, and I don't really need 0. To right, the farthest right it goes is 3. And it's actually a point there. So I'm going to go from left as a -3 to 3. And I'm putting brackets because I made dots there. It's not going on forever. And then for my range, I'm going to go from bottom, and this point is at 0, -3. I don't really need the 0, to 0, 3. So from the bottom to the top, it's going from a -3 to 3. Okay. All right. What I would like you to do right now is I would like you just to pause this video, try 3, 4, 5, and 6. Pause the video and see if you can figure out 3, 4, 5, and 6. Pause it. Pause it. Pause it. Okay. So if I go from left to right, these arrows really help me. The whole thing is covered. That's an easy one. -infinity to infinity. It never stops. But now if I go from bottom to top, the same thing is happening. This arrow, I'm going to delete. It's just going, right? And this arrow is just going. So if I'm going from bottom to top, I don't see those, but it's definitely going -infinity to infinity. It's going forever because of those arrows. Same thing with the domain on the next one. If I start at the right, these arrows are going on forever. So my domain is a -infinity to infinity. But here is where this gets tricky. If I start at the bottom and I go up, it doesn't go forever. It stops right there at 1, 2, 3, 4, 5. So at 0, 5. So I write it from the bottom. It's going down. So -infinity to 5 with a bracket. Okay, if you write it the other way and you go top to bottom, there are some teachers that teach top to bottom. I would not take off. I just am going to, I'm just always going to go from bottom to top because of the math, the upper level math that I teach. Okay, all right, so the next one, hopefully this wasn't too bad. That was a -1 to 1, 2, 3, 4, 5. So -1 to 5. And this was a -3 to a +3. So -3 to a +3. Okay. And then on the next one, same thing. Because of these arrows, it's kind of like that line on number 3. It's going on forever left and right. And it's going on forever up and down. Okay. All right. Go ahead and turn the page. I would like you to do, no, we're going to do, actually, I would like you to do 7 and 8 really quick. And then I want to talk about the next one. So do 7 and 8 really quick. All right, so on the domain, these arrows, it just looks like it's just going to keep bumping. My bump is terrible there. But so my domain left to right, it's going forever. My range is a little different though. My top is there, the bottom is there. So my range is going from bottom, a -3 is the lowest and 2 is the highest. Okay, this is going my domain left to right. I have nothing out here. The graph does not go there. So it's not going to -infinity. It doesn't start to a negative until a -1. But then it's going out. Now, because these are just going to keep going up, my range, my bottom to top is a -infinity to infinity. Okay. All right. The next one, the reason I wanted to do this one, my domain, it's staying 2 the whole time. It's a vertical line. So you literally just write 2. But my range from bottom to top, it is going forever. And the same thing happens on this. My range stays the same. My range stays a -4. And now from left to right, it's going forever. Okay. Now, the next two I would like to work. Okay, this gets tricky. This exists right here, -2. So my domain is a -2. And then it's going over here to this one, which is 1, 2, 3, 4, 5. But if you notice, it's an open circle. So you have to put a parentheses there because it doesn't actually hit. So my domain is a -2 to a +5. I'm going to erase all this so we can do the range. So if I start at the bottom, my first point is right here. And that's at a -2, but it's an open circle. And then if I keep going, just going to use a different color, it's here, and the highest point is right there. And then there's nothing again. So the highest point is at 1. And to me, it actually looks like it hits at 1, but some kids might argue we don't know that for sure. There's not a dot. So I put a bracket because it looks like it hits at 1, but it's fine either way. Okay, so same thing here. This is a closed circle here at 1, 2, 3, 4. So my over is a -4 is where it starts. And it ends at 1, 2, 3, 4, 5. So those are my left to right. My highest and lowest point, my lowest point is right here at 1, 2, 3. And my highest point to 1, 2, 3, 4. My highest point is right there at 5. Okay. I would like you to try 13 and 14. Okay, this arrow is saying it's going to keep going. So you're going to go -infinity to 2 with a parentheses because it's an open circle. And my range is a -infinity to 0 with a parentheses because that y is at 0. And then on this one, my domain, this is the farthest to the left. So it's a -2, and it's going on forever because of that arrow. And then this is also the bottom point, which is 1, 2, 3, 4. And it's going up forever because of that arrow. All right, so, and I know this is a lot of notes. This first section is a lot of notes. I forgot it was 3, but we're just going to roll with it and get them all done because, like I said, it's just a lot that goes together, and I got to make sure you understand it. Okay, so a function is a special relationship between values. Okay, this is the important part. Each input, which is our x, has exactly one output, which is our y. This is really important. Highlight this. Okay, this is like the real world. Everybody's like, when I never use algebra. This is like the real world. Okay, so I'm going to give you a couple examples here. So let's say you worked 5 hours and your paycheck said $100, and your friend has the same exact job as you. If they work 5 hours, their paycheck also better say $100. Okay, because it's one input, so there's only one amount you can make. Okay, another thing would be like in a dance competition. Okay, you're going to go on stage and you're going to dance, and they're going to give you a score. That it's one score. Okay, you can't get 17 different answers. It's one score. Okay, another example of this, like if you're a nurse and you're told your input is 3 pills, like that, it will only give you one output. Okay, you can't, it only happens once. Now here, there are things in the world that are not functions as well. For example, if I was on a Ferris wheel out at the fair and I measured my height off the ground, I am at the same height a bunch of different times. Okay, if I called my bank account and I said how much money is in the bank, they can't give me 7 answers at the same time. It's one answer. Okay, so a function is something that has, so like I'm going to write an example of a function, like 1, 2, 3, 8, 7, 1. So I have 3 different x's, okay? And now here is an example of not a function. 3, 10, 3, 12, 3, 8. Okay, you can't have 3 giving you 3 different answers. It can only give you one answer. So it's not a function. if it goes to different answers. So that's how you do this. So you determine yes or no. So I'm going to look at my x's, and I have 5, I have 3, I have 2, I have 0, I have 1. None of them repeat. This is a function. Okay? So now I'm going to look here. I have a -2, I have 0, I have 2, I have 3. Uh-oh, I have 2. Red flag. You got a 2 going to -4, and you got 2 going to 4. This is not a function. I know this seems really silly and like it doesn't matter, but it all will come together. And so it's really important you understand this. So if I look at the next one, red flag, -3, -3, not a function. Okay, and if I look at the next one, I believe I'm good. I have 1, 2, 3, 4, 5, boom, function. Okay. All right, so you can do this with a chart, and I don't think I'm going to do all of these because I think you've caught on. Okay, red flag, not a function. Okay, if I look at this one, I just look at my x's. They're all different. This is a function. So I would like you to pause the video, and I would like you to do 8 and 9. Pause the video, do 8 and 9. Okay, 8. Red flag, 4 and 4 go to 2 different answers, so this is not a function. And on number 9, I'm golden. They're all different, so it is a function. Okay, then I'm going to look at the map. Here's one of the reasons people like the map, and you're going to find, depending on what math and science you take in high school, you're going to find that you actually map things. So as long as all of these go to different things, which I only see one line coming out of them, they're easy. This thing is a function. But if I look at this one, red flag, it has 2 things coming out of it, not a function. If I look at the next one, they all are going to different things. I do not mean not. It is definitely a function. All right, and then the last thing we're going to look at is the vertical line test. And this is something you maybe have already learned. When given a graph of relation, the vertical line test can be used to determine whether the relation is a function. The vertical line test states if a vertical line intersects the graph more than once, it is not a function. Because if it intersects it more than once, that means that it has x's that are the same. So for example, if I make an example of a function, I draw a line. If I do this vertical line test and I take this and I just move this across, it only hits, every place it hits is 1 time. But if I were to make a circle, right? All I have to do is find one vertical line that hits twice, boom, boom, hits twice. This thing is not a function. So you don't have to keep making vertical lines. You just have to see if there's one. So for example, on 14, I can make a vertical line right there that hits both of those dots. It's not a function. But if I make a vertical line here, 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 it is a function because none of them hit 2 dots. Okay, so if I look at 16, I can take this vertical line and I can slide it up and down this vertical line and it only hits once. Okay, if I come over here, this vertical line right here would hit twice, right? And so that would mean that this one is a function and this one hits twice. You just have to find one, and so it's not a function. All right, so I would like you to do 18, 19, 20, and 21. Yes or no? Function, not a function. Make an actual vertical line. There we go. Okay, so if I look at this, this vertical line hits twice. So it is not a function. This one, I can slide it all the way across, right? Slide it all the way across and it never hits. So that would mean that this one is not a function and this one is a function. Okay, so if I take this vertical line and I bring it down to here, okay, wait. This thing goes, it hits all the time. So this thing is definitely not a function, but if I come over here and slide this line, that thing is a function. So this is not a function and this one is a function. All right, so that was a lot of notes to get through. So we will, you will have some homework with it. Like I said, this chapter is short, but it is very, it has very important